So sequence and series, let's have our definitions. So what is the difference between the two anyway? What's a sequence, what's a series? Well, a sequence, also sometimes called a progression, is just a set of numbers that follow some pattern. That's all a sequence is. It becomes a series when instead of putting a comma in between the numbers, we put a plus sign, and then it becomes a series. So it's when those numbers are added together. A, very creatively, is the symbol we use for the first term. But after that, we generally say term n, say term 2, 3, 4. I suppose you could put term 1 for the first term as well. Sn would be the series, so the sum of all those terms. So here's a simple little example. We've got some number pattern. It's defined by n squared plus 2. If we had to find the fifth term, it's just a substitution question, 27. We've got to work out, is 42 a possible term in this sequence? Well then, is it possible that n squared plus 2 could equal 42? Because remember, in these, n has to be a positive integer. So can I get a solution where this is a positive integer? Well, n squared equals 40. Well, no. Square root of 40, I won't get a positive integer as an answer. So no, can't happen. A recursive formula is another way of describing the pattern. And it does it by referring to previous terms in the pattern. So it will always designate what the starting term, or in some cases it might be terms, so the pattern known as the Fibonacci numbers. You need to know the first two numbers for that pattern. And then an expression then that will tell you how you can now generate every other term using the previous terms. So here's an example. We want the first four terms as defined by, well, the actual pattern is we'll get the term before it and add 3. It works for when n is greater than or equal to 2, because we need to know what the first term is. We couldn't create the first term with this because there's no such thing as the 0th term to sub in. So we need to know what it is. They've told us it's 4. So therefore, we can go, right, well then the next one will be 4 plus 3, 7. So then 7 plus 3, 10, 10 plus 3, 13, and so on. Here's another way. I talked about the Fibonacci ones then just before, but the Lucas numbers are also very similar to the Fibonacci, you'll notice. The actual pattern's the same. You add the two previous terms. The difference with the Lucas numbers, if you remember the Fibonacci numbers goes 1, 1. Well, the Lucas numbers, have a look at this one, that's interesting. The first one's 2 and the second one's 1. So what are the first 5 Lucas numbers? So we know it goes 2, 1. So to get the third one, we add the two previous ones. So the next one's 3. To get the fourth one, we add the two previous ones. 3 and 1 is 4. To get the fifth one, we need the two previous ones. So it goes 7. So it's a weird little pattern. It actually starts 2, then goes down, but then goes up. They're known as the Lucas numbers. There are two specific types of patterns we're interested in: arithmetic and geometric. So let's have a look at arithmetic. So what is an arithmetic series? So in this particular sequence, it's a very simple one. We simply add a constant amount each time. That's all it is. And we call that constant amount the common difference, and we give it the symbol D for difference. So I could say that the common difference is the second term, take away the first term. That would give me the common difference. Of course, I could have just as easily said it's the third term minus the second term. In fact, I could get any term, subtract the one before it, and it will work out the common difference for me. The recursive formula would look something like this then. So term n would be the term before it plus the common difference. So the first term is a. We said it's always going to be a. The second term, therefore, add on the common difference, a plus d. The third term, add on the common difference to the second term, a plus 2d. And we can pretty soon pick up a pattern to come up with a general formula. Oh, well, it must be a plus n minus 1 differences. That'll always give us any particular term. So we're told that the third term is 9, the seventh term is 21. What would be the general term for this one? Well, I know the third term, so a plus 2d, is 9. A plus 6d is 21. Basically, it's simultaneous equations. Now, we can work out what a and d are. And so d equals 3. A also is 3. So we get 3 plus n minus 1, 3. But we don't leave it like that, of course. We would want to simplify it. Expand that out. Collect like terms. and we just get 3n. This pattern is simply multiples of 3. So what would term 100 be? Multiples of 3. I guess that's 300. And what would be the first term greater than 500? So in other words, we're saying, when is that general term going to be greater than 500? 3n greater than 500, n greater than 503. But remember, n is defined to be a positive integer. So we want the first positive integer that is bigger than 500 on 3. 167. Now here's the interesting thing. How do we answer this question? It says, what is the first term greater than 500? So do I say, oh, it's the 167th term? Does that answer the question? Or do I actually write down 501? Well, that's why I put both down, just in case. So I say, okay, it's the 167th term, which is 501. If you were to plot these patterns, so term 1, so on the horizontal axis you put the number of the term, on the vertical axis put whatever the answer is. If you were to plot all these terms, you would end up with a linear function. Well, it makes sense when you look at the general formula. A plus n minus 1d, sort of like y equals mx plus b. You get the same thing. Time to play. Exercise 1a, exercise 1b. Welcome back. Now we're doing the HSC.